Welcome to the Transnet podcast. My name is Zimasa Vabaza. We are live from Durban at the Transport Evolution Africa Forum and Expo. And today we're looking at unpacking the different aspects of Transnet's input into our nation's logistics economy. And engineering is a major part of that. You might not think about it, but it really is. And today I've got Principal Engineer Mankonko Mabusela. How are you, ma'am, today?
Like every Zulu guy, you mispronounce my name. It's Mankonko.
Mankonko.
But I'll forgive you. It's okay.
Thank you. I'd love to be forgiven.
Yeah.
We'll engineer a better way of saying that. I'll do that. So please let me know, what do you do on a daily basis? Like, if you were at the office today, what would you be doing?
Putting out fires.
What type of fires?
So literally on my first day, I had a client come in and be like, I need this, I need that, and I need it done like right now. Yeah, so that's my daily. But besides, apart from just putting out fires, I am responsible for leading a team of engineers where we are responsible for supporting the maintenance and the manufacturing business. So we give a whole through life cycle product support, including obsolescence management, reverse engineering. We also try, or rather we provide skills by fault finding, and then we try to teach the people how to do that. With that, we want to retain the capabilities in-house and make sure that we do those services ourselves and functions ourselves, and also just to sustain the business. Basically,
Perfect. So I want to maybe go into specifically maintenance and the technologies that you guys are pioneering as TE. What are some of those, I'd say, those simple but very valuable ways of and technological advancements that you guys are doing in terms of how do you maintain our assets that are within the Transnet business?
Okay, so my department is responsible for supporting the power electronics business, which is the main manufacturing business. Those are like the components, the electronics components that goes on your locomotive. So we try to keep it very simple. But there's a state-of-the-art workshop where we have different test benches where you can test all these different components. And then apart from that, we literally go on the product itself, because most of the time what we get, the request that we get in the office is, okay, we have this component that is not working. Please make it work, and we need it done like yesterday. So one of our engineers would go there and then would try to get it working as fast as they can, and then afterwards we would transfer what we know, knowledge transfer, and then also transfer the capabilities as we know it, and then try to keep it keep it as simple as we can. The turnaround time, try to shorten it as much as we can by doing it ourselves and in-house.
Perfect. And I'm sure that also you give people the standard operating procedures of how to use the equipment and for longer lifespans, right? The stuff that you guys have made and engineered.
We do that. So there are different documentations that we would produce afterwards. The standard operating procedures, being one of them. But before that, there's a whole process that would take place, including the lab testing, where we have to make sure that before we put anything on the loco, it is proper and it's safe for operation. And then from there, we still have to do the in-service evaluation, where we put that same component on the locomotive to run for at least 6 months to make sure that it's operational. And then we also have, like I've mentioned, the test benches, where we, to make sure that we produce quality work or quality product, we have automated test benches where test reports will be automatically produced to eliminate the whole the whole human errors that might sneak in here and
They
there
might
when
crop
you are
up.
tired.
Yeah.
Like you just
Machines are never tired.
Yeah, machines are never tired. So let's keep it there.
Keep it there.
Yeah.
So I want to talk maybe a little bit about the manufacturing side of things. What innovations are you as Transit Engineering bringing into manufacturing? How are you assisting the manufacturing process of Transit? I think a lot of people don't really get to grasp and understand that Transit is in itself so many businesses, even within the ODs. Yeah. So when it comes to manufacturing, how are you guys innovating within that space, and what are some of the key things and projects that you have undertaken to really move the Transit's manufacturing forward?
So we do have different manufacturing workshops that we have from the RSE. We have the rotating machines. We also have lines for locomotives to be manufactured. I mean, the 1064, I think from Loco 10, if I'm not mistaken, I'll have to go back for that, up until where we were stopped because of whatever issues we had. We were able to manufacture it in-house. So there were state-of-the-art machinery where you're able to put together the different parts of a locomotive and test them, whether online or static testing within the workshop itself. So we did all the wiring ourselves. We have like a whole lot of technicians and artisans who are responsible for doing all of that. So we are quite capable when it comes to manufacturing and maintenance. So yeah.
Brilliant. And then I want to look at how are you guys dealing with sort of like sustainability when it comes to recycling of components, the reuse of certain components, and what are you pioneering within that space as TE?
Firstly, I mean, recycling, it's something, especially recycling of locomotives, is something that has been existing. It's not like it's starting now. Maybe it's like we're giving those things fancy names now. But if you look at the 18E, it comes from the 10E. Like your mechanical structures and all that, your propulsions and whatnot. Yes, those are the things that we recycled, and then just try to put whatever newer technologies that was available then. And then make it work. And also in terms of reusing components on a component level, there's obsolescence in components. So when, let's say for instance, a module would come and say, okay, we have this module that's not working, and for whatever reason, then you do your analysis, then you discover that it's because of an obsolete component or whatever. You have to go back and find an alternative.
Whether
or engineer it, whether you reverse engineer the solution or you find whatever component replacement of it, you still have to do it. So over and above that, we are able to find parts of the modules that are obsolete and then replace them, and then we go back and reuse the same module instead of chucking it out, all of it. However, people are chucking it out and polluting the environment and all that. So to reduce our carbon footprint, we try to keep what we can keep, and then modify it how we can modify it, modernize it how we can modernize it, and make sure that we reuse the same components. That is something that's existing, and we are actively doing it. Yes.
Amazing. And then I want to look maybe at a little bit into the future. Transit engineering is very much linked with research and development, and you guys are always trying to innovate and bring in new, I'd say, platforms, components, processes to the market. I want to then understand, relative to that in the future, where are you seeing the perfect balance where TE is assisting the business, but relative to maintenance and manufacturing? What does the future of that look like?
Now, I think TE is looking at the net zero strategy. I think it's everything that globally we are looking at. Investors are looking at that. I mean, they want to see you linking your strategy somehow to an ESG or some sort.
Yes.
Yeah. So like ourselves as well, we try to look around that as well. We have research and development projects where now we're looking at natural gases or use of
electricity
EV instead of just diesel or hybrid for that matter. How do we try to reduce that?
Our footprint.
Our footprint, So those are some of the projects that we are venturing into.
Brilliant. Thank you so much for your time. I think engineering is such an exciting thing for people that love to make things from scratch and also like to fix things that are going that are not going too great. But we appreciate your time. Mankonko,
yes.
Mabusela. You see, we engineered it.
Well done.
Principal engineer at Transnet. And I just want to say to everybody who's listening, visit unlocktransnet.co.za to find this podcast. It should be available by next week earliest. Thank you for your time. Thank you for your expertise. And keep engineering.
Thank you. Will do.